Hello everyone, welcome to this fifth video on the set theory. This video will talk about relations. So what is meant by relation? What are the different operations that can be done on a relation of sets will all be discussed in this video. Come on, we will get into the video. To define a relation, first we need to know what is meant by a Cartesian product. A Cartesian product of two sets A and B, which we denoted by the symbol A cross B, cross product B, is the set of all ordered pairs which are of the format A comma B, where the first element A comes from the set A and the second element B comes from the set B. So, the Cartesian product A cross B is the collection of all the ordered pairs A comma B such that A belongs to your capital A and B belongs to your capital B. Come on, let us see an example. Let A be the set which can be defined as X, Y and Z, and let B be the set that comprises of 4 and 5. Let us take the Cartesian product of A and B. So, how have we defined the Cartesian product? It is going to be the collection of all ordered pairs, but the first element comes from A and the second element comes from B. So, x comma 4 is an ordered pair. The next ordered pair is x comma 5. The next ordered pair is y comma 4. And now y comma 5. Next I have z comma 4 and next I have z comma 5. So, this is my Cartesian product A cross B. If I want the Cartesian product B cross A, then the first element will be from B and the second element will be from A. In which case, I'll be having it as 4 comma X, 4 comma Y, 4 comma Z, and next element of B will be 5 comma X, 5 comma Y, 5 comma Z. Notice that there is not going to be any mandatory order in writing this collection because this is merely a collection and it is not going to change by changing their positions. But we need to take in mind that x comma 4 is not the same as your 4 comma x. So, the Cartesian product A cross B is not the same as your Cartesian product B cross A. They are entirely different. So, note that A cross B is not the same as your B cross A. So, it is not the same. So, keep in mind the ordered pair where the first element comes from A, the second element comes from B is called as the Cartesian product A cross B. Next, we will move on to define what is going to be relation. A relation or a binary relation are from a set A to B is a subset of A cross B, which can be defined using A R B or A comma B belonging to R or R of A comma B. This relation is formed in such a way that it satisfies certain condition or criteria. So, from the Cartesian product, I am taking an subset that is going to satisfy any condition. So, this A cross B is going to be taking as a bigger set and I am taking R to be a subset of this Cartesian product. This is formed in such a way it satisfies certain norms. The norms vary from problem to problem. A binary relation R on a single set A is defined as a subset of A cross A. So, it is not always necessary that we need two different sets A and B. It can also be defined from A cross A. So, you can have a relation to be a subset of A cross A. And in which case, you call it to be a binary relation. And the cardinality, if they are going to be M and N for two distinct sets, then the maximum cardinality of the relation from A to B is going to be Mn. So this can be an MCQ kind of question. What is the maximum number of possible combinations I can take from this? The maximum number of elements in your relation will be m into n. Let us now have the relation or A to be defined as A related to B if A is less than or equal to B. So what is my Cartesian product A cross A? My Cartesian product A cross A is from A to itself. 1 1, 1 2, 1 3, 1 4, 2 1, 2 2, 2 3, 2 4, 3 1, 3 2, 3 3, 3 4, and I have 4 1, 4 2, 4 3 and 4 4. This is my Cartesian product. How have I defined my relation R? The relation R is defined in such a way that A is less than or equal to B. So from this I am going to take a subset where I am just going to collect the elements that are less than or equal to. The first number is less than or equal to the second number. In which case I will have 1 to be less than or equal to 1. Equality is also counted, so you can take 1. 1 is less than or equal to 2. 1 is less than or equal to 3. 1 is less than or equal to 4. Next, can I say 2 is less than or equal to 1? No. So this will not be a part of my relation, though it is a part of the Cartesian product. So I will have the condition now to begin with. 2 is less than or equal to 2, which is going to be 2. Now 2 is less than or equal to 3 and 2 is less than or equal to 4. So I take all these quantities. Is 3 less than or equal to 1? No, 3 is not less than or equal to 1. Is 3 less than or equal to 2? No, 3 is not less than or equal to 2. So I now ignore these two elements. Now moving on to the next element, 3 less than or equal to 3. Yes, 3 is equal to 3 and 3 is less than or equal to 4 is going to be true. Is 4 less than 1? No. Is 4 less than 2? No. Is 4 less than 3? No. Is 4 less than or equal to 4? Yes, it is equal to 4. So 4 less than or equal to 4. So I now see that R is going to be a subset of my Cartesian product A cross A. And how is this R formed? This R is formed by taking in the relation or the condition which has been imposed on the set, which is now given for this problem as A less than or equal to B. Next, we will move on to what is meant by domain and range. If there are going to be two sets A and B and a relation which has been defined from A to B, then the domain of the relation is defined as the set, the collection of all the elements A such that A comma B belongs to the relation for some B in B. And what do we call as range? So domain is the collection of all A's. What is going to be the range? Range is the collection of all the B's. So from the relation, if I am going to collect all the A's and form a set, they are called as the domain of R. And if I am going to collect all the B's, then they become the range of my R. Now let us take an example like A is the collection of 2, 3, 5 and B is going to be the set 6, 7, 8, 10. I define the relation A is related to B if and only if A divides B. So the condition is A divides B. Now how will I form the relation R? 2 divides 6, so 2 comma 6. 2 divides 7? No, so I will not take it. 2 divides 8? Yes, it's true. 2 divides 10? Yes, it's true. 3 divides 6? Yes, it's true. Does 3 divide 7? No. Does 3 divide 8? No. Does 3 divide 10? No. So I cannot take all these numbers. Next, does 5 divide 6? No. 5 divide 7? No. Does 5 divide 8? No. Does 5 divide 10? Yes. So I take 5 comma 10 in my relation. So now I have formed my relation. Now I need the domain of my relation. And what is this domain? The collection of all the A's in this ordered pair of R. So what is going to be my A? This first element is going to be my A. So the domain of R is now going to be equal to 2, 3, 5. And now moving to the range of the relation. And what is going to be the range? It is the collection of all your B's. What is my B? 6, 8, 10, 6 and 10. So when I go for the collection, it's 6, 8, 10. So I collect all the B's over here and write them as the range. Collect all the A's and write them as the domain. Next, I move on to the types of relation. A relation R on a set A is called as a universal relation if R is the same as my A cross A. That is, if the Cartesian product and the relation have the same number of elements, then it is called as a universal relation. Let A be 1, 2 and R is 1, 1, 1, 2, 2, 1, 2, 2. Then I know that A and A cross A or R and A cross A are going to be the same. So you call it as universal relation. A relation R on a set A is called as a void relation if the relation has no elements in it. Let A be the set 3, 4, 5 and R be the relation defined on it such that A is related to B if and only if A plus B is greater than 10. So I add these two elements, 3 plus 4, it is going to be 4, 5, 6, 7. 4 plus 9, it is going to be 4 plus 5 is 9. 5 plus 3, it's going to be 8. So I have no elements that satisfy the relation A plus B greater than 10. Hence my relation has no element in it. Next, an identity relation is the collection of all elements of the format A comma A where A belongs to A. So if I have A to be 1 comma 2 comma 3, then A comma A will be 1 comma 1, 2 comma 2, 3 comma 3. This relation is called as identity relation. Next, the inverse of a relation. What is going to be this? This is going to be the collection of all the ordered pairs got by interchanging the elements of the ordered pair in R. That is, my R inverse is the collection of all B comma A such that the ordered pair A comma B belongs to my relation R. So, if A is 2, 3, 5, B is 6, 8, 10 and R is the relation such that A divides B, then my R will be equal to 2, 6, 2, 8, 2, 10, 3, 6 and 5, 10. Now, what will be my R inverse? It is got by flipping your element A comma B. So, when you flip this element, it becomes 6, 2, 8, 2, 10, 2, 6, 3 and 10, 5. This becomes my inverse of the relation R. Now, let us move on to define what are the operations that I can do on a relation. Like if I have a set A and set B, the possible operations can be a union, an intersection, and complement, a difference. In a similar way, a relation can also take all these operations and operate on. So, if I am going to have a relation called as, let A be the set X, Y, Z and let B be the set 1, 2, 3. Let me define the relation R to be the collection X1, X2, Y3 and let S be the collection X2, Y3. Now, let us define what is going to be R union S. It is the usual union which is going to be your OR operator. So collect elements either in S or in R. So it becomes x comma 1, x comma 2, y comma 3, and x comma 2 is already here, so I don't write it. Y comma 3 is also already here, I don't write it. So this is my R union S. Next, R intersection S. Elements that are common to both A and B. And now here it is R and S. What are the elements that are common to both the relation R and S? It is x comma 2 and y comma 3. Next, what is going to be R difference S? The elements in R but not in S. So from the elements of R, remove elements of S. So when I remove elements of S, I will be left out with x comma 1. So that is my R minus S. Next, I define complement of R. So that is my R bar. Notice R bar is different from that of your R inverse. Inverse means flipping the elements. So what is going to be complement? Complement is nothing but elements that are part of your universal set but not a part of set. When it comes to relation, the universal set becomes our Cartesian product. So elements that are in the Cartesian product but that does not belongs to the relation. So from the Cartesian product A cross B, what do? We remove the elements of your R. So what is going to be my Cartesian product A cross B? A cross B now contains x1, x2, x3, y1, y2, y3, z1, z2, z3. From this Cartesian product, I remove the elements of R. What are the elements of R? x1, x2, y3. Whatever is left out will be called as the complement of R. So what is left out here? x3, y1, y2, z1, z2, z3. So these are going to be my complement of R. So in exam, be careful whether they ask you R complement or R inverse, because this is a common place where we will be making mistake on. I hope you people understood what are going to be the basics of the relation, the different types of relation and operation on relation. Hope this video helped you. Happy learning. Thank you.